Hi friends, this video we are going to see how to calculate the length of the vector, angles between two vectors and orthogonal of the vectors using given inner product space. First we start with the definition of length of a vector. Definition for length or magnitude. Let V be a vector inner product space then the magnitude or length of a vector let's say we call this vector x denoted by we called this one is a norm of the vector is defined by this norm of x we define square root of only the positive sign inner product of x comma x. This is a length of the vector. Okay, so now I take first we see one example. Let V equal to R2, X equal to the column vector 1, 3. So length of the vector is norm of mod x. So our inner product is inner product of x comma y equal to we define this V is inner product x transpose y. This way we define. So that implies square root of x comma x is nothing but square root of 1 times is 1, 3 times 3 is 9. So this is equal to square root of 10. This is the length of the vector. Okay. So we called this two double vertical line we called as a norm of x. Okay. Next is angle between two vectors. First we start with the definition. The real number theta in the interval 0, pi that satisfies cos theta equal to inner product of x comma y divided by norm of x times norm of y, or inner product of x comma y equal to, we say, r. Inner norm of x times norm of y times cos theta. Okay, so we define that theta is called the angle between x and y vector. So now we see two example. First two example we see. Okay, example 1, let v equal to r2, inner product x comma y we define as x transpose y. Now we want to find the angle between the vector x equal to 1, 2, y equal to 1, 0. We want to find the angle between two vector using this one. So what is the angle is cos theta equal to inner product of x comma y divided by length of x times length of y. So what is the inner product of x comma y is, because 1 times 1 is 1, 2 times is 0, 0, divided by length of the vector is square root of 5 times square root of 1. This is equal to 1 over square root of 5. So this implies theta equal to cos inverse of 1 over square root of 5. Now that is why I want to check it. Okay, this is the inner product change, the cos theta will also change. That is the same vector, but I define the inner product is different way. Suppose my inner product x comma y I defined as 2 times x1 y1 plus 3 times x2 y2, such a way that I define. So then my cos theta equal to inner product of x comma y divided by norm of x times norm of y. Okay, so what is the inner product of x comma y is 2 times x1. So our x is here, x equal to 1, 2, y equal to 1, 0. Using the fact x comma y is 2 times x1 is 1, y1 is 1, so we will get 2, y2 is 0. The length of the vector is 2 times x1 is 1, 2. So you will get square root of, so length of x equal to square root of 2 times 1 plus 3 times 2 square, that is 12. So we get square root of 14. Norm of y equal to square root of 1, 0. 1, 0 means simply we get 2. So square root of 2, we will get it as square root of 14 times square root of 2. You will get 1 over, because 2 commonly you take, so 2 is cancelled. So square root of 7 cos theta equal to 1 over square root of 7. This implies theta equal to cos inverse of 1 over square root of 7. You look the between two vector x and y, if you are changing two different inner product, you will get the two different answer. Okay, please be cautious. If you are changing the inner product, the angle between two vectors also can differ. Next is we are going to define what is the orthogonal. We are going to see definition of orthogonal vectors. Two vectors x and y in an inner product space are said to be orthogonal if inner product of x comma y equal to 0. So now we see first example. Let v equal to R2. The inner product I define x comma y is x transpose times y. So x equal to 1, 1, y equal to minus 1, 1. These two vectors I take and I say these two vectors are orthogonal used under this inner product. Okay, x comma y equal to x transpose. X transpose means 1, 1 in a row vector. Then our column vector as usual y. 1 times minus 1 is minus 1 plus 1 times 1 is 1. We will get 0. This implies these two vectors are orthogonal each other. So this implies x and y are orthogonal using this inner product. This is the first example. The same same vector, same inner product. I simply change the inner part only. Suppose my inner product is x comma y, where x comma y belongs to R2. I define, but my inner part is 2 times x1 y1 plus 3 times x2 y2. What will happen? Same, my x and y are same. My x equal to column vector 1, 1. Y vector is minus 1, 1. If I define the inner product x comma y equal to 2 times x1 is 1, y1 is minus 1 plus 3 times x2 is 1, y2 is plus 1. So minus 2 plus 3 equal to 1. So here x and y are, this is not equal to 0, okay? So are not orthogonal. So that is why. So two vectors are orthogonal in one inner product. It need not be another inner product. So these two vectors are orthogonal. I hope in this video you understand how to calculate the length of the vector and how to find the angle between two vectors and how to say two vectors are orthogonal or not. Thank you for watching this video.